Today we're going to look at 1.4 and 1.5, literal equations and application problems. First we're going to start with rewriting equations. So we're going to start with a perimeter problem. So we have P is equal to 2L plus 2W, and we're going to solve for W. So we want to isolate W. So we want to always add or subtract away from the variable we're trying to solve for. So I'm going to minus 2L from both sides. And because these are not like terms, just kind of make them like a little choo-choo train here. And then we still have 2W. So again, I want to isolate W. The 2 is being multiplied by the W, so I'm going to divide both sides by 2. And I can either keep this together or separate it. I'm going to go ahead and keep it together first. The other appropriate answer is where you would put P over 2 and then 2L over 2, which would reduce to L, equals W. So this is okay. If you want to take it that one step further to get this, that's okay as well. So that's the answer. The next thing we're going to do is we're going to solve for y. So given an equation that's in standard form, we're going to rewrite it into slope-intercept form. So again, we want to isolate the variable. In this case, we want to isolate y. So again, we always want to add or subtract away from the variable. So I need to get rid of the 10x. Then I'm going to have negative 18y equals, usually we put the variable first, so negative 10x plus 84. Again, they're not like terms, so I write them kind of like a little choo-choo train there. Now I want to divide everybody by negative 18. Whenever it's slope-intercept form, I usually do it individually, kind of different than what we did the first time, because we know we want to see the slope and the y-intercept. So a negative divided by a negative is positive, and then 10 and 18 both have a 2 in common, so this would be 5/9 x. A positive divided by a negative is negative. 84 over 18, so they both have a 2 in them, so that would make this 42 over 9. And then that also is divisible by 3, which would be 14/3. So we're just going to write it as 14/3. So this is the equation. Again, remember that's in slope-intercept form, where slope is the coefficient of x and the y-intercept is a constant. Alright, so the next part here we're going to do is looking for a pattern. So given a table of values, can we find a pattern and then write an equation? So the given table of values in this problem look like this. So we're going to have 0, 11, 1, 15, 2, 19, and 3, 23. So what we're doing is we're looking to see how x changes. And if we notice, x increases by 1. So for every 1 increase in y, or in x, what is y doing? So y is increasing. And then is y increasing at a steady rate? So is it a constant rate of change? So up 4, up 4, up 4. So it's increasing by 4. So what we have is a constant rate of change, otherwise known as slope. So slope, remember, is the change in y over the change in x. So in science, kind of steal their symbols, change in y over the change in x. So we have our equation. We want to write an equation after we do this. We're going to have y equals 4, that's where this guy came from, 4 over 1 reduces to 4, x, because we're writing in slope-intercept form, plus, you look back at the equation, and when x is 0, that's where the y-intercept, so when x is 0, the y-intercept is 11, and that's our equation. Alright, we're going to do one of those again. So we'll have x, and we'll have y. We'll have 0 and 46, 1 and 36, 2 and 26, 3 and 16. So again, we're looking for that constant rate of change, meaning that if it has that constant rate of change, it's a linear equation. So we look at this, and x is increasing because it keeps getting larger and larger. So as x increases by 1, what is y doing? Well, y is getting smaller, so y decreases. And how much is y decreasing by? Subtract 10, subtract 10, subtract 10. So y is decreasing by 10. So again, the slope is the change in y over the change in x. So we go to write our equation in slope-intercept form, the 10x, right, the rate of change, and then we look up at the points to see what the y-intercept is, so it's 46. Alright, so then we also have a rate of speed problem. On this one, we're saying that my speedometer is broken and I'm on Kellogg. Luckily, there are blue mile markers every 0.2 of a mile. I'm currently at mile marker 221/8. I time myself and it takes me 11 seconds to get to mile marker 221/6. Do I need to worry about getting pulled over? So if we look at this, I just want to know if I'm speeding. These are actually true mile markers that are on Kellogg. This one's at Kellogg and Webb Road. So if we look at this, we're talking about every 0.2 of a mile. So first off, I need to know how many 0.2 of a mile are there in a mile. So there's 5 of them. So that means that if I take the 11 seconds that it takes me to go from 1/10 to the next 0.2 mile, right? So how long it takes me to go from 0.8 to 0.6, took me 11 seconds. Well, since there's 5 of those, we would take 11 times 5 to get 55. So ideally, it would take me 55 seconds to go 1 mile. If we remember, mile, rate of speed in the highway is miles per hour. So that means miles goes on top, and the rate of speed goes on the bottom. So right now I have 55 seconds. I don't know about you, but my car usually says miles per hour, not miles per second. So I need to change this to hours. So seconds goes on top because remember we want these things to cross out and we want them to be diagonal, which means hours goes on bottom. There's 3,600 seconds in 1 hour. So we multiply straight across and we're going to take 3,600 divided by 55. And I get 66.4 or 65.45 miles per hour. So the question was, do I need to worry about being pulled over? And the answer is yes. So I need to slow down. Alright, so now what I want you to do is take the practice assessment that's linked on the website and to ensure that you're on track. It's going to cover sections 1.1 to 1.4. Again, this is kind of a self-assessment. I want to make sure that you know what you're going to do, what you're doing. The grade will go into the grade book. If you don't do so hot on it, then please come in and get some help so that we can work together and make sure that you're on track before we take the real test. Thanks.